not want to see Mark. So we came up all the way to this, and one of the arm in the back is missing. It was the claw. The arm is there. The claw is missing, and the claw we used to grab different materials. And the claw is missing because the student that built it, Ben Brote, he's probably our best engineer. He used it for one of his other projects for our class, and he's working on it still. He's working on improving the claw. So okay, so what it was it started with this bucket inside the robot. This is how we started in the robot starting box. And the objective was to go and collect different pieces from the field, and you bring it back to the robot starting box to score points. So it started with this, and we went and collected pieces in this, and that bin was already on the field. That was part of the field, and we would use both bins to score different points. Mitch, do you want to talk a little bit about the design process?
So, well, for the game itself, because for the robot, we had to design it to score different points for this game. So the theme this year was like a mine shaft type thing. So you had to go in and collect different resources from different areas and using different methods. So we used this bucket to, because there was a seesaw-like thing that was with PVC, had golf balls in it. So we would drive up to the one end, and then we would drop the bucket off, and then go to the other end of the seesaw and raise our arm up, and it would raise it, and then drop the golf balls into the bucket. And then that way we could go over, and we didn't have to try to scoop them up or anything, and they were all in one spot for us. And then we would take that over to a chute that had, it was kind of a flat piece with a support here, and when you hit the support, all this fell down, and it dropped a bunch of, there was foam pieces of coal, is what they were supposed to represent. And then we would catch that in there, and then we could drive it back to our scoring area and drop off the bin. And then so while our spotter was able to score those points, we could take the robot out and go pick up that bin that was already out there, and it was already had resources in it, so then we could take that and go score that without having to waste time. So then for the design process end of it, like you said, our Mark 1 was, it was a little rough. I think in our practice rounds, I think we scored
65.
Yeah, 65 points over like 5 rounds. I think we scored around 200 to 300 in a single round with this one. So obviously much better. And then from there, that was, the first robot we had was kind of a completely different design. It had a cardboard like X that rotated to try to kind of suck stuff up into it. And once we built that and tested it, we kind of realized that wasn't the best way to go about it. So after that, we kind of adopted this strategy with the different buckets. After that, the Mark 2 through 6 were all kind of around that idea with small variations. The arm, we never really got to where we kind of wanted it to be. It got us a couple points, but there were just some limitations with it that we didn't quite overcome. Yeah.
So the interesting thing about this project was this is in our capstone class in the PhD engineering class, and it's EDD, Engineering Design and Development. And all the students that are in this class come from different backgrounds. So there's different pathways that you can take through the engineering PhD program to get to this capstone class. So some people took computer integrated manufacturing, some people took digital electronics, some people took civil engineering and architecture. And all those skills come together at the end in the capstone class, and you work on this one major project for the entire semester. And so some people would do the electrical part of the robot, some people would design it, some people would actually build it. So that really helped. I myself took DE, digital electronics, and we do a lot of programming in there. So I helped with a lot of programming of the robot. So having different backgrounds, I think, really helps, and our PLCW program does a very good job in helping with that.
So for the best side, which we won an award for in Bowling Green, it, as Sam mentioned, has multiple portions, including spirit and sportsmanship, which was why you see pictures of our cheering block up there, which we did win first place for, because that's one of our spirit leaders up there. So we did a great job with that. Then there's also the exhibit, which is up there, and that's Sabrina and myself showing it off to a couple of judges. And that was really cool because what we had in there is we had a movable mine cart, because this year's project was all about mining. So we built a mine cart that you could actually roll around, and then we put a table on top, we displayed some of our stuff, and then on both ends of the exhibit, we actually had a couple of our students paint mine shafts. So it looked like as you were rolling it, if you kept going, it was going to go into the mine shaft. So that was really cool. And then we also had a presentation, which we were a part of, and we talk about our design process, we talk about our robot that we made, and then we also went into some portions that had to do with mining and things of that nature. So for our best portion, it was all handled by us as well as the other period, because there were 2 periods in this class. There's period 6 and period 7. So that was the first time this had ever happened, where there were 2 periods of EDD going on. So what we did is we had a competition, because you know, a little friendly competition always helps. So we had a competition at week 4, I believe, of the 6 weeks, where period 6 fought against period 7. Well, not fought, but you know, a little friendly fight against period 6 and period 7, and we ended up becoming victorious with this robot. And if our robot was rough, period 6's was, it moved a little bit. But so what we did from there is then we were able to sort of specialize. We were period 7 working more on the robot, period 6 was working more on the best stuff, because period 7 had already shown that they had a better design going forward with the robot. But kids could still choose. If they wanted to work on this, they could work on it. If they wanted to work on the other part, they could work on the other part. That way kids could decide what they wanted to do, what they would be best at, and what they wanted to learn about. So I, for instance, had taken digital electronics, just as Sam had. So I had never been in the shop that we have, which is insane, because from what I've learned this year is there's so much to do with that. So I learned how to use all of our woodworking machines, all of our metal machines. I learned how to mill and what milling is, because if you've ever talked to a kid in sim, they use milling like it's a verb, and I didn't know what that meant, but now I do. So I would say that this project has taught us more than any other class that I've taken, because I've just become so immersed in it.
I want to talk about something very important. That's the structure of the class. So as Mason mentioned, we had 2 different periods that took EDD. Now, Mr. Wilkins, he's taught us for the past 3 years, and he guided us, but he did not touch our robot, or he did not tell us what to do. This was entirely a student-led project this past entire semester. Before we did this project, we had a mechanisms project where we built different mechanisms. So he gave us the project, but he did not tell us what to do, and he did not tell us what to do with this robot. Like, if we were going to lose, he would tell us that we could do something to improve it, but he wouldn't tell us what to do. So we had to figure something out for ourselves. So I think that's very important as a senior, because it helps us learn what it's actually going to be like when we go to college and when we go into the actual field. And there's not going to be somebody sitting there by us guiding us on about what to do. They're going to give you the project, and you're going to have to figure out the constraints for yourself. Now, regarding this project, we haven't talked about the prizes we won, and I think that's very important. So we started doing this project 12 years ago, and around 12 years. No, the school.
Okay.
The school started doing this project 12 years ago, and around 2004. And ever since then, the highest award we've won is 3rd place in best and 3rd place in the robot game. And this year at Bowling Green, at the local hub, we took 1st place in best, 1st place in the robot game. We won the Founders Award, which is the best, the most innovative robot. We won the most robust robot, which means it requires the least amount of repairs. We won a participation award, and we won the Spirit of Sportsmanship Award, which you can see up there. Yeah, I'm really proud of my team. So part of the best project is the best part is the engineering notebook, and that's what Sabrina likes. So I'm going to hand it off to Sabrina, and Sabrina can talk a little about the process of how it was put together.
So basically, the engineering notebook just followed the design process of our robot. Again, this is Mark 6, and so with the notebook, I had to describe how we brainstormed everything, how we came to our decisions, how we implemented it, made designs, built it, tested it, kept going. So basically, it was just a loop. We kept going. Again, Mark 6. Mark 1 was just a piece of wood with wheels. Mark 2 had an intake that didn't work. Mark 3's intake didn't work, but at least it was moving around nicely. Mark 4, we actually started building this intake, which has our basket, of course. And then from there on, we had our competitions, and we looked at what we were scoring during the competitions and how we could do better. So with each one of the marks, we brainstormed new ideas. Like after Bowling Green, we came back, we're like, okay, what could we do better? I know we won, but what could we go and do better on? So basically, that's just how our engineering notebook is set up. Also, we have our decision matrices, which is how we decided each component of the robot and how to make it. Yeah, just a bunch of documentation to make sure that we have the best robot out there.
So we also brought a couple different things. This was part of why we won the Spirit and Sportsmanship Award. And part of that was helping others. It was to look good in front of everybody else, but it was also helping other students. So what we did was some teams didn't have so there's on the microcontroller, which is right here, which is basically the computer, which is the head of the robot. There's 10 ports where you can plug in motors, and 1 through 5 have one circuit breaker, and 6 through 10 have another. So if you plug in a motor in 1 and 2, and you jam the motors, it short circuits for about 20 seconds, and you can't move it around. So some teams didn't know that, and they were having different problems. So we helped them reprogram their robot and redo their wiring so it was actually working. So that was part of the Spirit and Sportsmanship Award, is that we help other teams and make sure that everyone is having fun. Like, we take the award, but we make sure So this was also, we had hard hats. Everyone was required to wear hard hats during the competition, and they provided us with hard hats, but we built our own. So this lamp is out of battery, but we chose the royal blue color. We put Rory the lion on it, and this is what all the drivers and spotters were wearing during the competition. Also, this is our shirt that we won the award for, Royal Robotics. And on the back it says, how far would you go for pay dirt? And pay dirt is the theme, and far go. So that's what we did, and I really think the engineering program is a very nice resource for students. I used to live in Arkansas, and my school did not have anything like this. We took core classes, and that was it. So moving here, that was a big change. And 3 years ago, I didn't know about the resources that we had when I was a freshman. I didn't know about the resources we had. And I'm just not realizing the potential that's available in the lab, in our woodworking lab, that we have. We can build so much stuff. We've done projects like we've built, students do different things. So me and Sabrina are actually planning on building Christmas presents for our mothers, a cutting board, and a jewelry box. And so we can do a lot of different things in that lab, and I think it's a very great resource and very great program that we have going on at HSE and Fishers as well. And if there's ever a vote or a chance for something where you could improve our program by any means, please, we would appreciate it very much.